Okay, so I wanted to show you how I set this up. Basically what I did is I put a punch mark here in the middle of this flange, and the way I lined it up was like this. I got a couple of parallels. These slots are 1/4 inch, so I have two 1/8 inch parallels jammed into the slots, and I have a piece of tool steel in the quill, and I just walked it over and lined it up vertically. I turned this until these were parallel to this, and that's close enough. I mean, we're not making rocket parts here. So now I'm going to do is drill the hole down, maybe, I don't know, it doesn't really matter, about 1 inch into it, and then we'll drill an intersecting hole this way to get the wires through. Alright, we're ready to rock and roll here. I center drilled it, and now I'm just going to run a number, 7 drill down there. Okay, now I'm going to run a tap down there, 1/4 I drilled the 750 thou. That's plenty. Doesn't even need to be that deep, but I don't want to short myself on the hole on the side there. So, yep, get a tap set up in there. Okay, so now I'm going to turn this thing, well, I'm going to drill the other one, and then I'm going to turn it and drill this way. Okay, I got both these housings done. Got the 1/4 hole here, and I just used the same tap drill to drill the intersecting hole. Now, I had to spot face it. It kind of nicks this hole right here depending on where you decide to put this. So just, you know, to keep the drill from walking off the center, I spot faced it with a 1/4 inch end mill, and now they line up. Then I ran a 1/4 bottoming tap down in there. So the only thing left to do now is make a couple of hollow bolts that fit inside of these lock line fittings. I buy a ton of these things because I use lock line for a lot of stuff. It's not necessarily just for fluid. So what will end up happening here is this will go on here with one of these bolts, and then the lock line will go on here, and then you'll have a flexible coupling for that. Now, what I've determined is the internal diameter, or the taper inside of this thing, is 22 degrees. So you want to have your compound set at 11 degrees because you got to cut this head on a taper so that it wedges in here and clears the little ball on the lock line fitting. So I'm going to set this up in the lathe and turn both of these down, the heads on these, to 11 degrees, 22 degrees included angle, and then I'm going to cut off a little bit because these bolts that I had in my stockpile are a little long, and then I'm going to drill a hole through the center of it for the wires. And then we'll be done with all the machining. What I'm have to do next is mount the LEDs inside of here, thread the wires through the hole, down through the bolt, down through the lock line, and we just mount them up. Alright, I got the compound swung over to about 11 degrees, and I'm just going to taper down the head of this thing. have to drill a hole right down through the middle of this bolt. So we'll get set up for that next. Okay, so this is a number 29 drill. It should be big enough to get the wires down there and not compromise the bolt too badly. These are stainless bolts, so you got to be careful about drilling in stainless, especially when you're doing deep holes like this. If you let the drill dwell in the hole, you'll work harden it, and then it'll pretty much be impossible to drill it. So I'm going in, you know, a quarter of an inch or so at a time here. When I feel that it's kind of getting tough drilling, I'll back it out, stick some oil on it, clear the chips. Right there, you can hear it. Probably slow it down a little. That was 450. I'm down to 350 now. Hear it. Just back it out, put some oil on it. Getting close in now to breaking through. When you get up near the end of the flutes here, you gotta clean them out. You don't want them to pack up, or the drill will get jammed in there and bust. Pull the drill out a little. We're getting up to the chuck here. Alright, we're through. So I'll just do that to the other quarter 20 bolt, and then we'll start assembling some stuff here. Okay, so both these bolts are drilled clean through, and the next thing you got to do is determine where to cut them off, because I got, you know, the ones I had in my stockpile are a little long for this, and it also depends on the taper. So you can see this, and now this will fit right down in there. Nice. And what I do is I put a nut on here to lock it. Okay. So now that's a stud that'll fit onto the end of a lock line. Now, what you want to do here is you want to thread this in, and you want the bolt to just come tangent to the hole so that you can get the wires to turn the corner and come out inside. So, depending on where you drill that cross hole, that's going to determine how long this bolt wants to be. So, typically what I do is I'll screw this in, and I'll take a Sharpie and I'll mark right at the face here. Okay, and the length of this will tell you where you want to cut it off. So this looks like 300 thousandths for this particular one. Now I drilled both of these in the same place, so what I'm going to do is I'm going to cut this off so that there's only 300 thousandths sticking out. Right now there's about 750 sticking out, so cut it off, and then we'll be done with the machining. We'll be able to solder the LEDs in and finish this light up. Okay, so just finished up the ends of the bolts on the Scotch-Brite wheel there, and I got this installed. Took this jam nut and jammed it up there so everything's nice and tight. Now, I don't think you can see it, but the bolt comes to a tangent on that hole, and here's I have just some typical wire that I use to do this, and thread it through here, and I have one of these little picks. You just guide it up through the hole. Okay, and these will be the wires that you solder onto the LED. I'm going to go in the house here and get some stuff and solder it in there. Okay, so here are the two wires. I mean, this is just arbitrary hookup wire I stripped out of something, and you know, I have it laying around. I think it's about 30 gauge, which is plenty for the 1 amp that's going to go through the LED. So you know, we'll do the other one, and then here are the original bezels and reflectors, and just put it together. Okay, so I'm back in the house here where all my soldering stuff is, and I've threaded the wires through both of these, and these are our two little 10,000K 10 watt LED modules. I'm going to put them in there, and one of the things you absolutely have to do here is use thermal grease. I'm going to take these 2 screws out of each of these, and I'm going to coat the back of the heatsink with some of it so that it bonds thermally to this shell. And I'm going to put a little dab of it right here so that the LED bonds thermally to the shell. And then I'm going to screw the LED in, and then I'm going to solder the wires to it. So I won't show you that on camera because everybody who's doing this probably knows how to solder. And I'll get back to you when we hook the drivers up and give them a test. Okay, so there it is, soldered in there. I got the heatsink paste on both sides of the shell, and I got it hooked up to the driver, which is right here. It's a 10-watt driver, runs off AC, and I'm going to turn it on and see what happens. Oh yeah, baby. Okay, so screw the reflector on there and we're done. Okay, so this is the way it is when it's done. Got the lock line fittings on there, ready to get wired into the machinery. Now, the original Cuppa Joe lights that I made back about a year ago had plexiglass lenses in them, and sometimes the chips would be hot enough to melt their way into them. So these have glass lenses in them, and I don't know if you can see this seal. Well, of course you can. There's a silicone seal around here to keep the spray oil and coolant out of it. It's got a nice reflector. That's the way it looks. And like I said, they're 10 watts and they run cool. So that's Rev B of the Cuppa Joe machine lights. I'm going to install these. I got 3 of them now. I'm going to install 1 on my lathe and 2 on my mill. And hopefully these things will last for a long time, because the original ones, they had these crappy little LEDs with drivers built into them, and they were 10 watts as well, and they just didn't last very long at all. I still have 1 left that's running, but 2 of them died. 1 of them died after about a month. 1 of them lasted almost a year. When you use these LED modules like this, you can adequately heat sink them, and you have way more control over the power in the LED with one of these drivers. Now you can get these to run off house current, which is what this one does, or you can get them to run off 12 volts. And I prefer these because they're just a little more robust. So, and you can wire them into the actual machine wiring. These things, they get to be maybe a little warmer than body temperature. They're sealed. They're potted. Can't do anything with them. They're fixed current. I think this one is 950 milliamps, and it's a constant current. It'll put out between 6 and 10 volts. These LEDs, when they're cold, they got a forward voltage of about 9 volts, and when they get warmed up, they're about 8.5. So that driver is perfectly matched to this little LED. So that's it. Thanks for watching. Have fun making one of these yourself. I'll put the links to the pieces. They're all off of Amazon. I think this driver was about $8 or $9. The actual light was originally it was $10, but I kind of negotiated with the seller because of some specs and stuff. These were advertised as 10-watt lights. What they actually came were 6 watts. So I told them I was only going to pay 60%, and they agreed to it. I bought 6 of them. They sent me back 24 bucks, and with that 24 bucks, I was able to buy some high quality, very nice 10,000K LED modules. These are industrial LED modules. They're copper, not aluminum, and they're going to last a long time. And they have that nice crisp white light, not that warm yellowish color to them. So what I paid for these was about $8 or $9 for the driver, about $6, well actually $6 for the housing with the reflector, and then these LEDs were $4 a piece. So it's a pretty cheap machine light. You know, obviously you got to do some stuff here. I don't know whether you could buy some heatsink material and just cut them around on a lathe. That might be a better alternative, but I happen to have the 2-inch bar stock, and it just works out that's a good solution to it. And you know, a couple hours worth of work, and you got some stuff here that's going to last a while and give you good light on your machinery. So thanks for watching. Okay, so here's a little color temperature display here. I'm hoping this shows up on the camera, but this is what I originally got, which is a 6,000 K light, and this is the other light, which is supposedly between 10 and 15,000 K. I just like the bluer kind of a light here rather than this yellowish one. I think it's better for looking at machinery. It's higher contrast. So I don't know, in the viewfinder it looks about the same, but I'm gonna have to look at the video and see what it looks like. This is 10,000 K, that's 6,000 K.